begin falling from the sky. As it plunges through Earth's atmosphere, temperatures will rise to thousands of degrees. Metal will melt. Modules will break apart. Solar panels will tear away. The station that once represented humanity's greatest hope in space will become a giant fireball streaking across the heavens. But here's the question nobody seems to be asking. If the ISS is one of the most valuable machines ever created, why destroy it at all? Why not save it? Why not turn it into a museum? Why not boost it into a higher orbit and preserve it forever? The answers reveal a hidden story involving politics, engineering, danger, and a race against time. Because the truth is, the International Space Station was never meant to live forever, and its final days may be more dramatic than anyone expects. To understand why the ISS must die, we first need to understand why it was built, and for that, we need to travel back to a time when the world was divided. The year is 1957. The Cold War is underway. The United States and the Soviet Union are locked in a battle for technological supremacy. Then something happens that changes history forever. On October 4th, 1957, the Soviet Union launches a small metal sphere into orbit. Sputnik, the world's first artificial satellite. The satellite itself was simple. It weighed less than many modern televisions, but its impact was enormous. For the first time in history, humanity had placed an object beyond Earth's atmosphere. A new frontier had opened. The space race had begun. Suddenly, space wasn't just science fiction anymore. It was real. And both superpowers wanted to dominate it. Within a few years, achievements began arriving at breathtaking speed. The first animal in orbit, the first human in orbit, the first woman in space, the first spacewalk. Then came one of humanity's greatest achievements, landing on the moon. The world watched as astronauts stepped onto another celestial body for the first time. But while the moon captured headlines, many scientists were thinking about something else, something that could transform humanity's future forever. A permanent home in space. Not a spacecraft that visited orbit for a few days. Not a temporary mission. A place where people could live continuously. A place where science could be conducted around the clock. A place where humanity could learn how to survive beyond Earth. It sounded impossible, but slowly, it became reality. Long before the International Space Station existed, there were pioneers, experimental outposts that tested whether humans could survive in orbit. The Soviet Union led the way. In 1971, they launched Salyut 1, the world's first space station. Compared to the ISS, it was tiny, cramped, primitive, yet it represented a giant leap forward. For the first time, humans had a place to stay in space. The mission was dangerous. Engineers were learning as they went. Every success revealed new possibilities. Every failure taught painful lessons. Over the years, more Salyut stations followed. Each one improved upon the last. Astronauts stayed longer. Experiments became more advanced. Humanity gradually learned how to survive in orbit. Then came Skylab, America's first space station. Skylab was larger than anything launched before it. It allowed astronauts to spend months in space. The lessons learned aboard Skylab would later help shape the ISS. But it was still only a stepping stone. The true breakthrough arrived in 1986, a station called Mir. When Mir launched, it looked modest. Few people realized it would become one of the most important spacecraft in history. Mir was different. Unlike earlier stations, it was designed to grow. New modules could be added over time. The station expanded year after year. Sound familiar? It should. The ISS would later use the same concept. Mir became humanity's first true long-term home in space. Cosmonauts lived there for months. Some stayed more than a year. Scientists finally began understanding what happens when humans spend extended periods beyond Earth. The discoveries were astonishing. Bones weakened, muscles shrank, vision changed. Psychological challenges emerged. Living in space was far harder than anyone imagined. Yet Mir also revealed something remarkable. Humans could adapt. The human body was more resilient than expected. The dream of permanent space habitation suddenly seemed achievable. But Mir's story was not all success. The station suffered fires, equipment failures, near disasters, collisions. At times, astronauts feared for their lives. Mir showed both the promise and danger of living in space, and it taught lessons that would prove invaluable. Because a much larger project was already being planned, one that would bring together nations that had once viewed each other as enemies. Few people expected it. For decades, the United States and the Soviet Union had competed fiercely. They raced to space, raced to the moon, raced to demonstrate technological superiority. But by the 1990s, the world was changing. The Soviet Union collapsed. New opportunities emerged. Scientists and engineers began discussing a radical idea. What if the next great space station wasn't built by one country? What if it was built by many? The concept was ambitious. The United States, Russia, Canada, Japan, European nations, all contributing hardware, expertise, and funding. Many doubted it would work. Political disagreements were inevitable. Technical challenges seemed overwhelming. Different countries used different systems, different languages, different engineering standards. Yet despite all obstacles, the project moved forward, slowly, painfully, but steadily. The International Space Station was born, and it would become one of the greatest examples of international cooperation in human history. Imagine trying to build a football stadium. Now imagine doing it while traveling at nearly 28,000 kilometers per hour. That was the challenge. The ISS could not be launched all at once. No rocket on Earth was capable of carrying such a massive structure. Instead, it would be assembled piece by piece, module by module, launch by launch. The first component launched in November 1998, a module called Zarya, built in Russia, funded largely by the United States. Even the first piece reflected international cooperation. A few weeks later, another module arrived, then another, and another. Astronauts performed spacewalks to connect components. Some spacewalks lasted more than 8 hours. Imagine floating above Earth with nothing beneath your feet. The entire planet turning below you. One mistake, one damaged tether, one equipment failure, and the consequences could be catastrophic. Yet astronauts continued, mission after mission, year after year. Slowly, the station grew. What began as a handful of modules became something extraordinary. A giant laboratory in orbit, a permanent human presence beyond Earth, a symbol of what humanity could accomplish when it worked together. But construction was far from easy. In fact, some moments came terrifyingly close to disaster. By the end of 1998, the International Space Station was still little more than a skeleton. A few connected modules drifting through space. Important, historic, but far from complete. The real challenge was only beginning. Over the next decade, dozens of missions would transform that skeleton into the largest structure ever built beyond Earth. And every mission carried enormous risks. Unlike construction workers on Earth, astronauts couldn't simply grab a ladder or call for help if something went wrong. Every bolt, every cable, every piece of equipment had to work almost perfectly. Because in space, even small mistakes can become life-threatening emergencies. The station was orbiting Earth at roughly 28,000 kilometers per hour. At that speed, astronauts weren't just building a space station. They were building it while racing around the planet every 90 minutes. One moment they would be flying above the Pacific Ocean. Minutes later, they would be crossing Europe, then Africa, then the Atlantic, then North America. Over and over again, day and night, sunrise and sunset, 16 times every day. Yet despite this incredible motion, astronauts had to perform delicate construction tasks requiring precision down to the smallest details. It was like assembling a giant puzzle while floating hundreds of kilometers above Earth. And sometimes, the puzzle fought back. Most people think spacewalks look beautiful, and they are. The view is breathtaking. The Earth below glows with oceans, deserts, mountains, and city lights. But astronauts often describe spacewalks differently. They describe them as exhausting, stressful, and sometimes terrifying. Every time an astronaut leaves the safety of the station, they enter one of the most hostile environments imaginable. There is no air, no pressure, no protection. Only a thin spacesuit stands between life and death. A small puncture could be fatal. A major equipment failure could become catastrophic. And then there's the psychological challenge. Imagine standing outside a spacecraft. Nothing beneath your feet, nothing above your head. Just endless darkness stretching in every direction. Many astronauts say that the first time they look away from the station, they experience a strange sensation. The feeling that they are falling, even though they are actually orbiting Earth. One astronaut compared it to standing on the edge of an infinite cliff. Your brain knows you're safe, but every instinct tells you otherwise, and despite years of training, that feeling never completely disappears. Yet, astronauts repeatedly ventured outside, installing solar arrays, attaching laboratories, repairing damaged equipment, expanding the station. Without those dangerous spacewalks, the ISS would never have been completed. But danger wasn't limited to construction. Sometimes, space itself became the enemy. At first glance, space appears empty, peaceful, silent. But appearances can be deceiving. Earth's orbit is filled with debris, millions of pieces of debris. Some are large, others are tiny. But at orbital speeds, even the smallest objects can become deadly. Imagine being hit by a paint chip. Normally, that sounds harmless. Now imagine that paint chip traveling faster than a bullet. Suddenly, it's a different story. The ISS has been struck countless times by microscopic debris. Most impacts are minor, small dents, tiny scratches, visible reminders of the dangerous environment surrounding the station. But not every impact is harmless. A larger object could punch through critical systems, damage solar panels, or even threaten the lives of astronauts. This danger never disappears. 24 hours a day, 7 days a week. Engineers on Earth constantly track thousands of objects orbiting the planet. Whenever a potential collision is detected, they calculate the risk. Sometimes the danger is small, sometimes it isn't. And when the risk becomes too great, the station must move. Imagine being forced to dodge invisible bullets traveling faster than sound. That is normal life aboard the ISS.